Download this code from codegive.com, link in the description below. Certainly. The numpy.arctan2 function is a useful mathematical function in numpy, which computes the arctangent of the quotient of its arguments, handling the signs of the inputs to determine the correct quadrant of the result. This is particularly useful in converting Cartesian coordinates, x, y, to polar coordinates, r, theta. Understanding numpy.arctan2. The function is defined as y, the y-coordinate, the opposite side of the angle; x, the x-coordinate, the adjacent side of the angle. The output of numpy.arctan2 is the angle in radians between the positive x-axis and the point given by the coordinates, x, y. The result is in the range /pi, pi/. Why use numpy.arctan2? Quadrant awareness. Unlike the simple arctangent function, arctan, y/x, which can only yield results in the first and fourth quadrants, arctan2 can correctly determine the angle based on the signs of both x and y. Avoid division by 0. Arctan2 avoids the division by 0 that can occur when x is 0. Code example. Here's a simple example that demonstrates how to use numpy.arctan2. Explanation of the code. 1. Imports. We import numpy for numerical operations and matplotlib for plotting. 2. Coordinates. We define arrays for x and y coordinates. 3. Calculation. We use np.arctan2, y, x, to calculate the angles in radians for each point. 4. Conversion to degrees. We convert the angles from radians to degrees for easier interpretation. 5. Output. We print each point's coordinates along with the corresponding angle in both radians and degrees. 6. Plotting. We use matplotlib to create a vector plot of the points, showing their directions from the origin. Output. When you run the code, you will see the angles corresponding to each point and a plot showing the vectors originating from the origin, 0, 0, to the points defined by x, y. Conclusion. Numpy.arctan2 is a powerful function for angle calculation in a two-dimensional space, allowing for a straightforward way to handle the direction of vectors. This is particularly useful in fields such as robotics, navigation, and physics.